Have you ever wondered how Einstein's theory of relativity changed our understanding of the universe? It is a cornerstone in the world of physics, a game changer that revolutionized how we see space, time, and gravity. Imagine our universe as a giant fabric, distorted by massive objects like stars and planets. That is the picture Einstein painted for us. But this was not a masterpiece he crafted overnight, nor was it a solo endeavor. The road to this groundbreaking theory was filled with twists, turns, and even a few bumps. But did you know the journey to this groundbreaking theory was not a smooth ride? Let us take a moment to understand what Einstein's general theory of relativity is all about. In essence, it tells us that what we perceive as the force of gravity is actually the curvature of space and time. Imagine a trampoline with a heavy ball in the middle. The ball causes the trampoline to sag, creating a curve. Now, if you were to roll a smaller ball onto the trampoline, it would naturally roll towards the larger ball, not because of a mysterious force pulling it, but because of the curve created by the larger ball. Likewise, light also curves along the curvature of space-time. In this analogy, the trampoline represents space-time, the larger ball represents a massive object like a star or a planet, and the smaller ball represents a less massive object moving in the gravitational field of the larger object. In addition, speed and/or gravity causes time dilation. The metaphorical internal clock of an object will run slower the faster it goes, or the closer it gets to a massive object, such as that of a black hole. This is a simplified way of understanding how Einstein's theory changed our perspective on gravity, from a force to a geometric property of space and time. Now that we have a basic understanding of the theory, let's delve into the story of its creation. Did you know that Einstein did not work alone on his theory? Indeed, the development of the theory of relativity was a team effort. Einstein had his own intellectual posse, his allies in the realm of theoretical physics. Among them were Marcel Grossmann and Michel Basso, who played crucial roles in the evolution of the theory. Grossmann, Einstein's close friend and fellow mathematician, was instrumental in the incorporation of the complex mathematics that underpin the theory. He helped Einstein navigate the labyrinth of tensor calculus, an essential mathematical tool used in general relativity. On the other hand, Michel Basso, a respected physicist, provided Einstein with valuable insights and feedback, helping to refine and polish the theory. Their collaboration was a testament to the power of intellectual camaraderie and shared pursuit of knowledge. However, the path to scientific discovery is seldom smooth or straightforward. Even with the collective brilliance of Einstein and his allies, they encountered roadblocks along the way. But even with help, the initial formulation of the theory had some hiccups. Can you imagine that the early version of Einstein's theory of relativity contained a major error? Yes, even geniuses can make mistakes. In the initial stages of developing his groundbreaking theory, Einstein stumbled upon a significant miscalculation. The major math error was the miscalculation of the amount a beam of light would bend due to gravity. This error, however, did not stop Einstein. He worked persistently, refining his theory until it was free of inconsistencies. But the journey was far from smooth sailing. A mathematician named David Hilbert, once a friend of Einstein, stirred up a controversy. Accusations of plagiarism were thrown into the mix, adding fuel to the fire of an already complicated situation. Hilbert claimed that Einstein had borrowed heavily from his work, casting a shadow of doubt over the originality of the theory of relativity. Despite these challenges, Einstein's theory prevailed, but not without a real-world test. Did you know that Newtonian physics was unable to accurately predict the motion and position of Mercury? Yes, you heard it right. For centuries, the precise path of Mercury as it carves its way around the Sun remained an enigma. Newton's laws of motion and universal gravitation, although incredibly successful in describing the movements of other planets, fell short when it came to Mercury. It was a tiny discrepancy, but a persistent one. This is where Einstein's theory of relativity steps up to the plate. Einstein's theory, unlike Newton's, accounted for the curvature of space-time, caused by massive objects like the Sun. And when applied to Mercury, the results were remarkable. Einstein's theory of relativity was able to accurately predict the motion and position of Mercury, down to the minutest detail. This was a major victory for Einstein's theory of relativity over Newtonian physics. The significance of this prediction cannot be understated. It was the first real-world evidence that Einstein's theory held water. It was a foreshadowing of the successes to come and a major stepping stone in the eventual acceptance of the theory of relativity. This triumph over a long-standing problem in physics was a clear indication that Einstein was on the right track, despite the controversy and errors that surrounded his work. It was a beacon of hope in a sea of skepticism. So when we talk about the confirmation of Einstein's theory of relativity, remember the story of Mercury, the little planet that could and did validate a groundbreaking theory. Do you know what made Einstein truly famous? It was not the mere publishing of his paper on general relativity. Rather, it was the confirmation of his theory by none other than British physicist Arthur Eddington. In the year of 1919, during a total solar eclipse, Eddington ventured to the African island of Principe. His mission? To perform the first experimental test of Einstein's general theory of relativity. Eddington's observations during the eclipse provided the much-needed evidence to validate Einstein's theory. The results were astounding, and they catapulted Einstein into the limelight. Yet it is important to remember that the road to this confirmation was not a straight one. It took many years, countless calculations, and a lot of patience to confirm Einstein's revolutionary theory. In fact, even at the time of Einstein's death in 1955, scientists still had almost no evidence of general relativity in action. It truly was a theory that was ahead of its time. But as we have seen, it was a theory worth waiting for. Today, we see evidence of Einstein's theory in our everyday lives. From the GPS technology that guides us on our journeys, to our understanding of the universe and its workings, the impacts of Einstein's general theory of relativity are all around us. So, the next time you look up at the stars, remember the long road to confirmation that this groundbreaking theory had to traverse. Did you know that without Einstein's general theory of relativity, we would not have GPS? It is a fascinating truth. Einstein's theory, born over a century ago, is deeply woven into the fabric of our daily lives. His concept of general relativity, a bedrock of physics, impacts us in ways we seldom realize. The most prominent example is the Global Positioning System, or GPS. This technology, which guides us from point A to B, relies heavily on Einstein's theory. The satellites in space and our devices on Earth must account for the distortions in space-time caused by Earth's mass, as described by Einstein. Without adjustments for these distortions, our GPS coordinates would be off, leading us astray in mere minutes. But it is not just about getting directions. Einstein's theory has broad implications in fields from astronomy to telecommunications, shaping our understanding of the universe and how we interact within it. So, next time you use GPS, remember to thank Einstein and his revolutionary theory of relativity. Wow, what a journey we've been on! Together, we have navigated the labyrinth of Einstein's theory of relativity, from its initial conception to its profound impact on our daily lives. Let's take a moment to reflect on what we've learned. We started with the mystery of relativity, delving into the complexities of Einstein's groundbreaking theory. We saw how he stood on the shoulders of giants, building upon the foundations laid by Newton and others, yet also how he faced controversy and error. We then delved into the pivotal moment of confirmation, when the rest of the scientific community finally accepted the theory. This was a turning point, not just for Einstein, but for our understanding of the universe. And today, over a century later, Einstein's theory of relativity continues to shape our world. From GPS systems to astronomical observations, relativity is a fundamental part of our everyday experiences. But perhaps even more importantly, Einstein's journey teaches us about the power of curiosity, perseverance, and audacity in the face of skepticism. It reminds us that science is an ongoing process, a journey of discovery, filled with challenges, triumphs, and constant learning. So as we wrap up this exploration, we encourage you to keep questioning, to keep exploring. Who knows? Maybe you will be the one to uncover the next groundbreaking theory that will shape our understanding of the universe. Remember, Each one of us has the potential to be the next Einstein. So keep looking up, keep wondering, and keep exploring the mysteries of our universe.
Thank you for watching. Hope you found this video informative and entertaining. Please subscribe, like, share, and comment. We do like to know and hear your feedback. And if you have the means, please consider supporting us on Patreon, where you can get early access to our videos, and where we post bonus material. Till next time, this is Geeky Tidbits saying cheers and have a good day.